Is that Starbucks?
You know you can't drink Starbucks in the lab.
You know you can't wear open-toe shoes in the lab.
Ziggy X. They got one more problem with you, girl. Hey. Hey, baby, even though I hate you, I wanna love you. I want you. And even though I can't forget you, I really want to. I want you. Tell me, baby, why can't you leave me?
To be honest, I don't know why they would want to drink coffee anyway. It's so bitter, especially after the dehydration process that goes on after roasting CGAs, aka chlorogenic acids. Chlorogenic acids make up 8% of unroasted coffee beans. There are over 40 different types of chlorogenic acids. The chloro and chlorogenic acids refer to the light green color that the unroasted coffee beans have. There are no types of chlorine atoms in these structures. In light or medium brews, the main source of bitterness comes from chlorogenic lactones. They form by the addition of hydroxyl groups to transamidic acids, which degrade during roasting. During roasting, they hydrolyze to phenolic acids and dehydrate into chlorogenic lactones. In darker brews, the products that break down from these chlorogenic acid lactones add an even more bitter taste. This explains why espresso coffee is one of the most bitter coffees. Sarah, why, is there any benefits to coffee?
Yes, coffee is actually full of antioxidants. Now, you've probably heard of antioxidants, but I'm going to explain to you how they work. Now, in the body, there are these compounds called free radicals. And free radicals are actually ionized molecules and atoms in your body. Now, these can form from exposure to UV radiation, exposure to pollutants in the air, or even just by eating certain unhealthy foods. Free radicals, because they're missing an electron, because they're ionized, they take electrons from other cells in your body. And that causes the cells to degrade and can cause cancer and premature aging. Now, antioxidants, they donate an electron to the ionized atoms that are free radicals, and therefore stabilize them and prevent them from oxidizing other compounds in your body, hence the name antioxidants.
Ah, see. Hey guys, I brought SPF 100 so that we don't get tan, because I know you guys want to keep your pale, pasty skin.
Of course not, Jen. We do want a tan.
SPF stands for Sun Protection Factor. This SPF 100 means that we can stay out for 100 times longer than if we didn't have this on. So this means that we don't get burnt as easily, and we won't tan as easily either.
Some inorganic chemicals, including minerals such as zinc oxide or titanium dioxide, act as a physical sunblock. They reflect UV rays, similar to how white paint reflects light. The white-colored noses on beachgoers in the 1980s and 1990s were due to these compounds, because manufacturers make the inorganic particles much smaller now. We don't see the visible white. Along with inorganic chemicals, sunscreen often contain organic chemicals with names such as avobenzene or oxybenzone. Instead of physically deflecting UV light, these molecules absorb UV radiation through their chemical bonds. As the bonds absorb UV radiation, the compounds of the sunscreen slowly break down and release heat.
In the process of sun tanning, the melanocytes in your skin react with UV rays from the sun to produce melanin, which is a brown pigment that causes the tan look in your skin. In self-tanner, there's an active ingredient called DHA, which is a sugar. It reacts with the amino acids that are in the dead top layers of your skin cells. When there is heat added, such as the sun's rays, and they produce a final product that gives off a brown tan. Fun fact, this same reaction, which is called the Maillard reaction after the scientist Maillard, is the same reaction that happens when you cook steak, chicken, or your favorite foods. It turns brown and it has that good taste. Exposure to these UV rays causes some skin cells to produce this pigment melanin, tan pigment, which darkens because of the process of oxidation, the same process that turns apples brown.
Oh my god, we're gonna be late for the hoodie concert.
Guys, I'm ready for the hoodie concert. What are you wearing?
We didn't mean actual hoodies.
Let's go get ready! Wait, Ginny, you need to have straight hair if you're gonna be a white girl. Alright. So have you ever wondered about hair straightening?
Not really. Yeah! Oh my gosh. I mean, yeah, because I straighten. I'm so interested in it.
Well, when your hair is being straightened, it goes through a 300 to 500 degree Fahrenheit iron, and the protein that is in hair, known as keratin, it contains long chains of amino acids that have sulfur atoms on them, and these sulfur atoms, they covalently bond to produce disulfide bonds, and these disulfide bonds, when heated, they're then ripped apart, and they can bond in a new formation, like a straighter formation. Isn't that cool, Jenny?
That's so cool. I've always wanted to know that, you know?
Hey Jenny, look out! Jenny, why'd you let her get your hair wet?
Oh, wow. I'm sorry.
I just spent hours doing your hair.
Right. I'm really sorry.
Do you even know what water or humidity does to straighten hair?
What? What does it do?
Well, the water or humidity, it contains extra hydrogens, which then they attach to the hydrogens that are already in the amino acid chains of the keratin, and then this abundance of hydrogen bonds causes the chains of keratin to hold in on themselves and thus creates a wave, and now your hair is wavy and you can't be a white girl.
Oh no! We're getting ready for our hoodie concert too. Ah, dumb me.
Jenny, you are now a white girl.
Oh, so much for thank you guys. I'd like to thank all the white girls, Maya, Molly, Talia, and Sarah, Mr. Sanson for all my chemistry knowledge, and the Academy, maybe not the Academy, but yeah. Thank you guys.
I can't even.
I'm just literally so proud. I'm like dying.
Oh my god.
YOLO!
Hello.
We should do the chemistry of dogs.
Hey Jenny, look out!
Oh, Starbucks.
Wait, no, we're not doing it yet, right? You have to.
We haven't hung out in forever, and I really miss you. You're so pretty. That's so white girl.
TBH.
I'm so fancy.